Okay, so welcome back to everyone. And we are down to our last set of presenters. So finally, our last team is composed of Prince Ralph Emmanuel P. Ramirez, Simon Matthew S. Santillana, and Carlo P. Romulo from Wesleyan University, Philippines, Team B, along with their coach, Leo M. Ramos.
And their research is entitled Harnessing Wave Energy and SOS Communication System. So now to tell us more, let's welcome Team 5.
Hello. Good morning, judges and ladies and gentlemen. My name is Simon Matthew S. Santillana of Team B of Wesleyan University of the Philippines. And today, we will pitch our entry, this university's entry, and along with my teammates Carlo Romulo and Prince Ramirez, our title is Project I Buhawe. I Buhawe, which means inverted buoy for harnessing wave energy. This is inclined with this year's theme of the squeeze, which is the key is clean and affordable energy. Project Buhawe will produce electricity to the waves, ocean waves rise and fall. This is done through the system's rack and pinion mechanism. Rack and pinion mechanism is the reason why we named it Buhawe. Buhawe is coined from the term from the Tagalog word of the tornado, which means it can produce vigorous amounts of rotating motion. Our system can also produce vigorous amounts of electricity through its rotating mechanism. Project Buhawe was put forward by us due to the Philippines being an archipelago that has many or large population of small-scale family-based fishermen. In this case, a form of buoy may help our local fishermen to utilize a new renewable energy. Communication and safety problems is also becoming a problem due to recent issues in the West Philippine Sea, and especially the Philippines having so many natural disasters. Through these predicaments, we the researchers created this innovative system, an inverted buoy that has also a GPS and a GSM communication box that may help our small-scale family-based fishermen. The GPS will be used by sending a text message, and it will send an SOS distress signal to registered recipient. In terms of accessibility, our buoy can easily be attached to existing boats. Thus, modernization of old boats will never be an issue. Our buoy is powered rack and pinion mechanism, which drives the rotary motion of the generator, which then produces the electricity. The mechanism of connected circuit are as follows. The buoy is then connected to the SOS controller, which is powered by a Neo 6M that is connected to the 433 MHz RF receiver, and we also have a communication box which is powered by an Arduino Nano, so we can have more flexibility on our proposed designs, and also had a SIM module, which is the SIM 900, which is connected to our Arduino Nano. This system may be hindered due to difficulty of material gathering, difficulty of on-site testing, and mastery of construction due to us being only electronics engineering students. In conclusion, this system will be helpful for our local fishermen for new ways of safety, comfort, new ways of renewable energy, clean and affordable. Lastly, this will be helpful for our future researchers. Thank you, judges, for listening and watching our presentation. May we all hope for the betterment of our environment through clean and affordable energy. Now, together with my teammates, Carlo Romulo and Prince Ramirez, we may answer any inquiries regarding our project.
Okay, so thank you so much, Team 5, for that intriguing demonstration regarding your research. So indeed, Ibuhawe is a complete package, and we do appreciate the cohesiveness in the presentation of the simulations we saw to better understand how the mechanism works. And so not only is it clean and affordable, they've also mentioned that it is in order to help our local fishermen. And so what do you think, Donna?
Yeah, I definitely agree with what you said. And I'm very impressed with their video presentation. They even provided us with the actual 3D model of Aibuhawe. So now we may now proceed to the Q&A portion with our judges. So again, judges, please turn on your camera to commence the start of the Q&A portion.
Okay, so our judges are now ready. So judges, you may now start asking your questions for Team 5. Thank you.
So maybe I can start. So one is my first question is I'd like to confirm that you cannot use the buoy when the boat is in motion, but only when it's in standstill, right? That's one. And number two, how do you contemplate this being used? Is it a lead acid battery that's fully charged when the fishermen leave the port, and then while they're fishing, the rack and buoy generator will just continue to recharge the battery and therefore result in a case where there's only the first time charge on the battery, and then afterwards it just kind of self-sustains.
Thank you for your answer, sir. Our project Ibuhawe can only be used in idle position, and it can harness wave energy through the ocean waves rise and fall.
Okay, and I guess so currently communication systems or SOS systems on fishermen boats, do they exist or they don't exist at all?
The communication system is not existing, sir.
Okay, so you're introducing a safety measure for our fishermen, I guess, right? Okay, thank you.
Yes, sir.
Hello, good morning. So my question is, what's the expected range of operation for the communication system?
So based on previous researches, the estimated value of the range of the GSM is 8.1 kilometers, but it may vary depending upon actual on-site testing.
So 8.1 kilometers, is that enough for the fishermen to reach the cell site for the GSM?
Sir, thank you for that question. The module we use, or the GSM, is tested on the previous research, which is in 0.4 kilometers. The first trial was 21 seconds, so it was able to send the proper coordinates to the registered recipients. In 0.7 kilometers, sir, the trial is 21 seconds as well, and follows to the 1.0 kilometers, 2.1 kilometers, 2.3 kilometers, and to 8.1 kilometers. In an actual on-site actual testing, we will improve the range of our, or we can use the amplification to extend the range of our GSM. So it depends on the actual site testing, sir.
So dependent din yung site niyo kung dun sa cell towers bale na around area.
Yes, sir.
Okay. So yun kasi yung concern kasi baka mamaya dito, you have a SOS communication system, tas hindi naman niya kaya mag-communicate with the desired na communications. So yun, that's all my question. Thank you.
Yes, sir.
Okay. This is Cyrus here. Thank you for that presentation. For my first question, will your design affect the center of gravity or the center of balance of the boat, given that it's located on one side of the boat and it's not balanced on the other side? Have you taken that into consideration?
We didn't consider it, but upon actual on-site testing, we may consider it. And our buoy is very suitable for any kind of boat.
Okay, just try to consider that when you do the
Yes, sir. Yes, sir.
and when you do the trial, the center of balance of the boat. With regards to the based on your design, I see some motors and some I don't know, the rack and pinion. Do you need to waterproof it, and how do you plan to do it?
Regarding the waterproofing, sir, we will use an IP68 rating, which will be used in our SOS communication box and communication device, as IP68 is very suitable in extreme weather conditions, especially in the sea.
Okay. With regards to the sending of the SOS, how does it work? Is it like a satellite phone? When you use satellite phone instead of a regular mobile phone? What's the process on that? Does it based on nag-base ba siya doon sa mga telco or hindi?
Thank you for your question, sir. This is based on the GSM module, sir. So
Hindi
it
na ako
will be
familiar
based
sa
on
GSM
telcos.
module.
It will be based on the telcos, yes.
So your scenario would be probably walang dalang mobile phone yung fisherman or something na nalobat yung fisherman? Yung ba yung scenario?
Yes, sir. Yes, sir. Yes, sir.
Okay. And when it comes to storm, how will this work? Will it work when there's a storm? Because that's the time that you should be utilizing yung SOS signal.
Just like existing GSM devices, it will still work in bad weather conditions. However, this will cause attenuation in the free space po, sir.
Sorry, what's the last word?
In free space po, sir. It may work, but it may produce a signal that is not very efficient, sir.
Because
In addition, sir, it can still work in bad weather, but the rainfall may cause attenuation in free space. Thus, it can produce unreliable signal. In this scenario, an amplifier can be added to improve our system, sir.
Yes, sir.
Okay. So with regards to the first question, that it will not be working while the boat is moving. So does it apply during a storm? When you say not moving, is it when the boat is not on a certain speed, or what's the criteria for that?
The boat is in the standby mode, yes, sir. It is in idle position, sir.
So if it's a storm,
Sir, our buoy can easily be lift up, and it is only mounted in the side of the boat, sir.
so it means that if there's a storm, you could not use this.
Yes, sir.
Okay. That's it for me. Thank you.
Hi guys, you mentioned earlier that this is you have a prototype of this already done previously. Is that correct? Or somebody did it?
No, ma'am, the module we use or the components we use, there is a previous study or testing, or like the GSM module, the range of the GSM module we use. There are past research, ma'am.
For the GSM module. But in literature review, this rack and pinion wave component how is your research a novel version of that?
Sir, ma'am, our project is novel because we are using an invert buoy system, and according to our research, there is no existing similar system in the Philippines, which is small scale. Since we are targeting individual fishermen, we ensure to minimize the installation and maintenance costs. Thank you.
And is this what was the previous uh sort of model for freshwater or saltwater?
Saltwater, ma'am.
All right, thank you.
Wait, just to clarify, the device is only active when the SOS button is pressed, right? Otherwise,
Yes, sir.
it's idle.
Yes, sir.
Okay.
I'm just thinking, no, because I don't know if this is the actual setup of this is what it actually looks like, but you would need to lubricate those gears. Is there parang how do you plan to lubricate that and for the lubricant to not fall into the water?
So we will lubricate it upon construction po, ma'am.
No, not what I mean is for maintenance because you're exposed to salt water. Obviously hindi naman forever nandun yung lubrication, you'd have to reapply that.
So our construction, ma'am, will be very accessible to local fishermen as they can maintain it by themselves, sir, ma'am.
Hello.
Oh, sir.
So want, I just have to clarify something. Our suggestion, you may say. Kasi tawag dito, since hindi pwede gamitin yung system while di ba, while moving. So paano kung you encounter a fisherman kunwari na hindi niya binababa kapag nasa stable position na siya. Hindi niya binababa yung buoy. So basically hindi ma-charge yung battery, di ba? So maybe you can add a indicator kapag yung state of charge ng battery is low na para malaman ng fishermen kung kailangan nilang ibaba na yung buoy. Kasi right now, di ba, I don't think if that feature exists. Pero kasi di ba, you're saying na hindi pwedeng gamitin yung system while moving. So paano kung hindi siya binababa ng fishermen? So I think you have to see that that perspective then. So improvement lang din sa project.
Thank you for your suggestion, sir. We may add it upon actual on-site testing and will vary depending on the actual cost and efficiency of our product, sir.
And this should be easy with Arduino Nano.
Okay, sir.
Sige, yan lang. Thank you.
Thank you, sir.
Judges, do you have further questions? Okay, so that is the end of the Q&A portion. Thank you to our fifth team and our judges. Hopefully, the participants were able to take note of the inputs and comments from the discussion.
Indeed, Donna. So once again, thank you, Team 5. And now I think that everyone is drained from presenting and listening to various researches in these fields. So I don't know about you, Donna, but I'd like a quick break.
You're not alone on that sentiment, RD. And I'm sure everyone is quite tired, so we will be having a short break so that we can all relax and freshen up as our judges will be deliberating on the results of today's competition. So, judges, you may now proceed to the judges' breakout room. While everyone, please be back by 11:45 a.m. SquEEEze, the 24th National Triple E Competition and Convention, is brought to you by UP Circuit and is co-presented by First Gen Corporation, Texas Instruments, and Maxim Integrated. This event is also in cooperation with Force Hero.
Squeeze is also made possible by our official organization partners, Institute of Electrical and Electronics Engineers UP Diliman Student Branch, FEU IT Electronics Engineering Students Society, FEU Tech Electrical Engineering Students Association, Organization of Electronics Engineering Students, Institute of Integrated Electrical Engineers, Western Mindanao State University Student Chapter, Institute of Integrated Electrical Engineers, PSU Student Chapter, Institute of Electronics Engineers of the Philippines Incorporated, and PUP Engineering Network.